And then that, like, just drawing the pentagon would be considered skeletal?
That's the skeletal structural formula. Jessica? I thought the question was... Jessica asked a question.
That's what I was saying. Was you asking somebody else?
Yeah, Jessica asked a question.
Okay.
Her hand was up a long time ago.
What player? Oh yeah, I need to learn how to do this. She doing what? She doing number 112.
Okay. So number 112 says this is taking place where?
In water.
In water. So that means that if it's a soluble compound, it will be aqueous. That's right, it will dissolve, and it means it will be aqueous, okay? So to find out the physical states of these two compounds that I've already listed, we use the solubility rules. Okay, now, before we do that, let's talk about the classifications equation, because that's going to make a difference in how we handle it. What kind of compound is this? What classification of compound is it? It's an ionic compound. And you know that because there's a polyatomic ion right there. Okay? If it's an ionic compound, it's in two parts, or at least two parts. We got an A part and a B part. What class of compound is this? It is ionic because it's a metal bonded with a nonmetal. That's the other way to tell from a formula whether it's an ionic compound. So two ways to tell if you have an ionic compound: the presence of a polyatomic ion, or that it's built from a metal, non-metal, in a structure like that, okay? And so that would be C and D. So this is going, if we're going to have a reaction here at all, this is going to be double replacement. Two-part compounds that switch places, okay?
The first part, if it's ionic, it has what?
It's got a metal and non-metal.
No, that's the second part.
Okay, this compound, you can tell this compound is ionic from the formula because it contains a polyatomic ion. PO4 is a phosphate ion, polyatomic ion. Right, common ions list is where you get it. This compound, you can tell, is an ionic compound because it's made of a metal-non-metal combination. Okay? All right. So if a reaction is going to occur, and this is a big if right now, the front part of this has got to go with the back part of that. And finding out if the reaction moves forward is all about the products with a double replacement reaction. So we have to figure out what the product is going to be to see if we can have a reaction. So let's do that. Na is going to go with Cl. Okay, and this goes to Jessica's question earlier. The subscripts don't travel unless they're part of a polyatomic ion. So this 3 doesn't travel over here. This 2 doesn't travel over here. The 4 would travel in PO4. So we're going to put Cu with PO4. The front part always stays the front part. Yep. Yes. So we're going to put Cu and PO4 together. Okay? Alright. Now, these are not balanced formulas yet. But I don't want to balance them yet because I want to know what physical states I'm going to have over here, because that's going to tell me if the reaction even occurs at all. Okay?
Is it double?
Well, I don't need another classification. I've already done that. I didn't know if there's a driving force. The driving force for a double replacement reaction is the formation of, what's in the products? The formation of solid, the formation of water, or the formation of a gas. Okay? So I don't have any water here. So that one's out. Nothing here would make a gas. So that's out. The only driving force that's available to me now, because I've eliminated the others, is the formation of a solid. So that's what I use the solubility rules for. So here's sodium chloride. And in the very first solubility rule, it says that all of these are soluble. They're in the soluble section. Group 1 salts. Well, sodium is in group 1 of the periodic table. It's in the first column. So this is a group 1 salt then, and this is soluble. It says it's soluble here, and there's water around. The problem says so, so this has to be aqueous. Yes. What? Yes. Figure out whether this one's going to be soluble, please. Use your solubility rules. You need someone to go with you? You're okay. Go by yourself.
No, like it's already on my hand. It's like,
You shouldn't be putting those things on your hand in class.
do you read it? It's already on my hand.
Oh.
I'm gonna have to take an after school chemistry. That was failure in my I'll probably have to go 40 because everything I get.
You gonna be okay by yourself? All right. Okay. All of you who are just now talking, is this solid or aqueous?
Solid.
Okay, how do you know that?
Solid.
Okay, so phosphates, it says down here on the solubility rules, are insoluble, except when they're with group 1 or ammonium. Well, that's not group 1, it's not ammonium. So therefore this is going to be not aqueous, and therefore a solid. So we do have a driving force. Now we can do everything else we need to do.
So if that first one isn't in group 1, it makes it solid. I mean insoluble.
If it's not group 1 or ammonium, then this is going to be, if it was a group 1 metal combined with phosphate, it would be aqueous. Well, that's what we had over here. This is a phosphate that has a group 1 metal attached to it, so it is aqueous. Put AQ here. Okay? Alright. We need to figure out this one here. Well, chlorides are listed right here, and it says chlorides are soluble. If there's water around, that means it's going to be aqueous. Unless it's combined with silver, not silver, combined with lead, not lead, or mercury 1, not mercury 1. So this is aqueous. If it's soluble, it's going to be aqueous if there's water around. Okay? Now we have to balance these formulas. Can't balance the equation until I balance the individual formulas. So I need to know the charges on these ions. Where do you find the charges on monoatomic ions?
The kind of iron, please.
No, that's where you find polyatomic ions. Oxidation number, periodic table of oxidation numbers.
That's what I mean.
Okay. So sodium has a 1 plus charge. Chloride has to be a 1 negative charge. The only negative charge that's available is a 1 negative. And it has to be negative because you can't get it to be neutral if you don't. Okay? So if sodium is 1 plus and chlorine is 1 negative, it's going to be 1 to 1 because 1 plus 1 negative equals 0, doesn't it? So I don't need to do anything with that. Let's go over here and find out about copper and phosphate. Well, how do you know it's 2 plus and not the 1 plus copper? Which one? How did we figure that out? We need to figure out what it was here. If it's 1 plus over here, it's going to be 1 plus over here. If it's 2 plus over here, it's going to be 2 plus over here. Okay, let's see how you figured that out. Huh?
Wait, no, isn't it just 1 plus because it's not even?
Well, let's figure it out. We have to figure out its oxidation number here. So what is the charge on the chloride? It says so right there. We've already done that. -1. We don't know the charge on the copper right now. We've got to figure that out. Okay? So we know we have 2 chlorides. So let's say 2 times 1 negative. We know we have 1. sorry, plus. We know we have 1 copper, 1 times some charge number we got to find.
1 times 2.
So it needs to be a 2 plus. Okay, so that means this has to be a 2 plus. And if it's 2 plus here, it's 2 plus there. So this is going to be a copper 2. Okay? What's the charge on the phosphate? Where do you find that?
5 plus.
Phosphate's 5 plus? Phosphate.
Oh, which, I was looking
You
at
got a lot going on with this.
3 negative.
3 negative. Okay, well, let's see, phosphate with a 3 negative, okay? So let's see, I'm trying to figure out how many coppers and how many phosphates. So I've got a 2 plus with some coefficient I don't know yet. I've got a 3 negative with some coefficient I don't know yet. And I got to have the whole thing equal 0. Everybody understand what Shane's saying, how he got it? 3 and 2. So I got 3 coppers and 2 phosphates I'm going to need. So that means this is going to be a subscript 3 here and a subscript 2 there. Okay? And now we're ready to balance the equation. Now that the formulas are balanced, we're not going to touch the coefficient, the subscripts. Okay? We're only going to use coefficients to balance the equation. So can you do that? Please do that. Balance
I
the
thought you
equation.
couldn't add in subscripts.
What now?
I thought you couldn't add in subscripts.
You have to add subscripts to balance the formulas. But once the formulas are balanced, then you don't touch it. Yes?
So you don't put the 3 in front of the 3 and then put it in the front.
When we're balancing the formula, we use subscripts to balance the formula. Once the formulas are balanced, you can't touch this. And then now, once the formulas are balanced, then you use coefficients to balance the equation. Everybody got it?
Yeah.
So that's balanced right there.
The formulas are balanced now.
For like.
Okay? So you're going to balance the equation now. And what is it we use to balance equations?
The chart.
Atom inventories.
EI.
Yeah.